Hey there, this is Hetty Jones, and today we're talking about large language models. LLMs, as they're called, have emerged as one of the most powerful and most versatile artificial intelligence technologies of our time. So by training these massive neural networks on these vast data sets that are human-generated text, LLMs are now ones that have developed this unprecedented ability to actually understand and generate human-like language and with robust fluency, and I would say comprehension. So this breakthrough has really unlocked a wide range of innovation and applications across many industries. Right now, we're seeing things like content creation, language translation, data analytics, conversational AI assistance, and even code generation. More recently, OpenAI released ChatGPT 4.0. They say that it can reason across different modalities in real time. So they train this single model end to end across text, vision, and audio, meaning that all the inputs and outputs are processed by the same neural network. So it's still early day, but this idea of developing a multi-modal model has this potential to actually create more effective outputs and yield better decision making in the future. So welcome to Tech Uncensored. The nascency of this technology has yet to be fully really understood. Image, language, audio understanding, the generation capabilities that can drive substantial productivity gains and enable new forms of human and machine collaboration, and even question whether human jobs are replaceable. This is all still emerging. So as well, LLM technology currently have limitations. They have risks. They have issues when it comes to factual inaccuracies. They have biases that we've seen in the old guard of AI from training data. They lack common sense reasoning. And there's this pervasive potential for misuse. And more recently, the data privacy implications, as we've seen from OpenAI's unconsented use of Scarlett Johansson's voice. So there are techniques out there like retrieval augmented generation, which a lot of the researchers call RAG. And they are highlighted as promising approaches to help ground the LLM knowledge and improve their accuracies over time. So I am so pleased to welcome Amir Faizpour, CEO and founder of AI.Science, which is a platform for expert in the loop business workflow automation. And I've known Amir for many years, and he is just the right person to actually take us through everything about LLMs. And we'll cover the transformative impacts of this technology across the different sectors, the applications of both present and future. What are the risks and challenges to LLMs, and what does this mean for startups actually developing in this space? So welcome, Amir.
Thanks for having me, Hessie. I'm excited about our conversation.
I'm excited too. Okay, so let's start with you because you've been doing artificial intelligence for a while. So why don't you take us through your background? You've also developed this amazing community of researchers and developers all over the world that have done some amazing collaborations in this space. Tell us how this all started and why you are here.
Sounds good. So just to give you, I guess, your audience a quick history, I'm a quantum physicist by training. I did my whole academic journey of PhD and postdoc and all of those good things. But at some point, I decided to move to industry. And the very first thing I tried was a quantum tech company. And, about a decade ago, that was just too early. And I decided that the next best thing was AI, and very much immediately fell in love with natural language processing because the ability to do computation on text was just crazy to me at the time. And, when I saw it, I was like, what is this? How can I make my life about it? And, that's what I've been trying to do since. I worked as a data scientist and then later a product person at one of the financial institutes. It was a fun gig, but I was pretty bored at my corporate job. I think the bug of being an entrepreneur was in me. And one thing that I started doing on the side to entertain myself, but also to keep up with the rate at which information was being released in the space of AI, was to build this community. And it literally started by a bunch of us gathering every week, eating pizza and talking about AI. That was 6 years ago, and that's still going on. Now we gather online, obviously in a post-pandemic world, but the same type of vibe still exists. We hang out every week, talk about advances in AI, build together, learn from each other, and teach each other.
Can I ask how big your community is at this point?
So we have more than 5,000 AI researchers and engineers globally, depending on how you count, but that's one of the metrics that we have.
Yeah. Thank you. So let's dive into LLMs right now. We have the current limitations of, I guess, machine learning, and whether or not, I guess, that's now considered passé. Does anybody say machine learning anymore?
I do.
Okay. So okay, then it's true. Then it's still here. So is it safe to say that LLMs are a natural evolution within the artificial intelligence space? And so tell me how they work.
Yeah, definitely. So, I mean, when it comes to artificial intelligence, one of the very critical signs of intelligence is language use, right? Like if we look at the animal kingdom, we are one of the animals that has a very, very complex capability of using language. And some aspects of language, like storytelling specifically, is tied to cognitive revolution that happened to Homo sapiens. So as modern humans, we've been very, very interested in replicating that capability in machines, right? So like from 50s, 60s, when we were interested in expert systems, we always wanted to say, how can it talk back to me? How can it understand what I'm saying, right? And obviously the progress has been very, very slow, 5, 6, 7 decades. But finally, language models are like the large language models. Like language models have been around for more than people probably realize, but the large ones have been around for the past 3 to 4 years, and they just completely, brought the game to a new level, which wasn't a step function change. Like it was a gradual change over the past, 3 to 5 years. But yeah, definitely they have brought the game of modeling language to a very different level. Although, to address what you said earlier, they don't necessarily replace a lot of the other types of machine learning that we've been doing. Like they're not necessarily good at time series forecasting and recommender systems and reinforcement learning and all of those other types of machine learning that we've been doing. So they're like their own category that potentially interfaces with all of the other types of intelligence categories.
Okay, so what specifically differs about them in terms of the technologies or that they use?
So there are two important differences with other types of machine learning technologies that we have developed previously. One is just the sheer amount of data they're trained on. Like in a lot of previous types of machine learning that we have done, we usually had like a limited amount of data. Like it was the largest data sets were the transaction data within this enterprise, or variations of that idea, right? Or the watch time of YouTube videos. So it was usually like super specific and narrow in terms of what the data was and what we could do with it. But with language, because of the variance that it has, because of the abundance that it has, especially with the internet, we had just so much data to train on. So that's one aspect that is very different. So the amount of available data that still needed to clean it and turn it into high quality training data, but just the amount of available data was so large, which in turn allowed us to train very, very, very large models. And these are ginormous models, and only very few entities can train, at least with the current architectures that we have. So that's one aspect of it, just the size of the data, the size of the model itself. The second aspect of it is, what it is trying to do. So the previous types of machine learning that we were interested in, they were generally speaking single trick ponies, if you wish, right? They're what we call narrow AI. So they were capable of, I give you a bunch of data points about market, predict where the market is going, like a time series forecasting for the market, or I show you what kind of videos Amir has watched, recommend what he would be interested to watch next, right? But with language models, we are doing something slightly different, which is we are saying, here is all the text from the internet and all the code and all the data sets that exist on the internet. Learn what's the likelihood of, if I give you these few words, what's the likelihood of the next word? And just learn this about the whole internet, right? And that's interesting because all that we're teaching it is, if you see text, this is the most likely next piece of text. If you see data, this is the most likely next piece of data. If you see code, this is the most likely, that sort of idea. That's what we call autoregressive training. And once it learned that, it was large enough that all of a sudden it just, quote unquote, internalized a lot of patterns that existed in this. So that's why it can just connect the dots and be like, I wouldn't write an article that sounds like Hesse Jones wrote it. I want to write an article that is like, I don't know, Harry Potter, but Barack Obama wrote it, right? So it can just extrapolate from all of these different places into doing it, doing the tasks that we're asking it to do. There are a bunch of other nuances like instruction fine-tuning, RLHF, etc., that made them even more robust in doing so, that we can get into. But that's really, those two are the biggest differences versus the more traditional machine learning.
I think the one thing I want you to address is this idea of the generative adversarial networks, because is that considered a big component of this as well, in being able to generate I guess coherent text or outputs. Is GANs part of that solution?
So GANs were sort of the baby steps towards generative models. Like even the image-based GANs mostly were used in image space, just to generate images. And even the early versions of them, they were pretty decent, but they had a lot of problems. And the current models do not use that GAN architecture anymore. Like they're diffusion based. In text, we generally speaking, the conceptual idea, which is, I'm gonna give you a bunch of things and generate some result, and I will tell you what is good and what is bad. The same idea does exist here, and the whole red teaming thing, for example, is an example of sort of that idea taken and changed a little to say that you're a large language model, you're responsible to generate text. I'm gonna try my best to break you. Try your best to undo that, right? So that's sort of where these sort of conceptual ideas overlap.
Okay, and so just for our audience, the idea of red teaming is sort of a way to create more accountabilities in the systems by trying to, I guess, from the outset, almost like fool the network. Is that right?
Yeah, essentially, you want your large language model to behave in a certain way. The idea of red teaming is like, the training, like you're a boxer. That's a training you do. Like you throw the boxer into a ring with somebody else and you say, just fight. The goal is to, make sure that your, boxer gets really good at predicting what kind of, punches are going to come towards them and, be good at reacting to those. That's exactly the same thing you're doing with LLMs. You're going to say, this is going to be in the wild. People are going to interact with it. We have no idea what they're going to do. So let's try our wildest ideas, ask it to do all sorts of crazy things, and make sure that the system is robust and can handle those gracefully.
Okay. So let's talk about some of the big players here. We have Anthropic, we have Gemini from Google, we have Llama from Meta, and we have OpenAI. Like, why do you think at this stage there has been so much interest and even adoption for these large language models?
I mean, just the use cases are remarkable, right? Like the number of um, the number of use cases that rely on unstructured text data is huge, and that's generally untapped because of the narrow AI capabilities that we previously had. We made a lot of progress on what we call structured data, like time series forecasting, recommender systems, anything you could put in tables. But on a structured data, which is video, audio, image, and text, are things that started happening later, more recently. But language was the very hard one because we could get language to be kind of sort of close, but not exactly as good as these large language model were able to do that. And the adoption is simply because everybody was so thirsty for having these types of capabilities. Um, and if you think about them, the way those types of capabilities are happening today is that we don't have any good way to automate them because they're very fuzzy. It usually requires a level of knowledge to know how to handle them. Um, at least language knowledge to read something and react to it. And all of a sudden, LLMs are giving us those capabilities. So we are able to consider for the first time automating those things. I've been trying to throw around this term that I'm trying to spin called knowledge ops, which I think is a continuation of DevOps, data ops, ML ops, and it is knowledge ops. It is really operationalizing knowledge intensive tasks that were not available to us before this.
Okay. So I want to get into the point about these large language models, like how they're generated, and we know that there is indiscriminate scraping across the web. I don't think anybody ever thought about the privacy implications of just taking the web and saying, I'm going to put it all into all these data sets that we're going to train from. So address the idea of like, there's only a few companies that have the ability to scrape the internet and develop models from that, from a cost perspective. So what happens with other companies who use, let's say, the APIs from these models, and they fine tune them for themselves?
Yeah.
What is, I guess, even from an ownership or control perspective, how does that work in the new world?
Yeah, I mean, that's a very unresolved issue. Like we are in very, very early days of figuring out how this might work. Probably a lawyer is or a copyright person is in a better place to comment on what it should look like. But currently, what is happening is essentially, as you said, they've used the data from the internet without necessarily even asking, can we? The very good old trick of, ask for forgiveness. And they are now trying to ask for forgiveness in a bunch of lawsuits that he's, gone through them. They're going through. Um, but, the fact is that they created, like OpenAI specifically created a model that was the first product market fit, the first two product market fit, which means that they have their traction, which in turn means that they have the capability of generating a lot of new data that is not necessarily even available on the internet. Like famously, their human feedback data was acquired. Like they just hired a bunch of people to annotate that data, right? Even underpaid from, I heard, like I don't know if that's true or not, but I have again heard that they're actively hiring data annotators, like people that you would sit down and solve puzzles and write your reasoning or any type of human activity. I wouldn't be surprised if they're hiring people actively to sit down and annotate data for those kind of things, right? So they definitely have the momentum, resources, and technology to collect data at a rate that nobody else can. So that's definitely concerning. But at the same time, open source has not been, inactive either. Like, we're seeing a lot of open source models. Some companies, for whatever reason, like, Meta, for example, are open sourcing a lot of the models they're building, which is an interesting play. And, again, like I don't have the knowledge to know what is the politics of doing so, but at least the fact is that it is enabling a lot of the community to keep up and build independent models and fine tune independent models. Uh, so the question of, what's the structure of the ownership is going to look like, what's the right economy around it, all of that are very interesting questions, and I don't know if we know answers to them. But what I'm hopeful about is the fact that, like, one potential outcome could have been that everybody kept the models close to their chest and said nothing in the open source, and no open source project was supported, and that would have been really bad. But at least the fact that there is activity in the open source community, and at least some of the community companies feel that it is important to support those movements, I think that's positive. Hopefully there will be some forces in the market that create a new balance that is better for everybody.
There's actually, I think, a friend of mine who works with, I believe, the Biden and Harris government, where they're trying to do this. I think it's the executive order for AI ethics. I don't even know if it's called AI ethics, but the idea that they could potentially audit you as a company so that you have to be a little bit more open about your model, regardless of which model you end up using, but that it's supposed to do what it was intended to do, and it's also open to testing to ensure that there aren't any potential downstream effects. I think that's coming. The question is whether or not those companies that have been black boxes will be forced, unless legally they're forced to open up the hood and to be more transparent about these things.
Yeah, I mean, I have a bit of a cynical point of view about regulation in general. I don't find it very effective. The challenge with regulation is that it's usually several years behind where it needs to be, and very, very slow to be implemented. And more importantly, companies know in and out of how to get out of them, right? Like, just make the appearance look right and move on. So I think what the saving approach might be is just to enable entrepreneurs. At Altitude Accelerator, that's exactly what you're doing. Like, just find entrepreneurs who are ambitious, enable them to build alternatives, and make those alternatives available on terms that are more suitable, right? Like, create a competition, and that competition is going to create a new balance in the market.
Yeah, I think so. But there has to be, you have to instigate a little bit morality, or just in them, because I mean, at the end of the day, is that it is innovation, but can we structure the innovation so it could be more, I would say, moral. All right, so let's get into some misconceptions about generative AI. I'm going to throw a couple of things at you, and you tell me whether or not it's a myth or a fact, and why. So LLMs can think or reason independently like humans.
Yeah, that's one of my pet peeves. I've been talking to a lot of very knowledgeable, like mathematics PhDs and such, about this topic. I don't think there are good answers. My position is that they do not, because they're based on statistics, and statistics by definition is not causal. And in order to be able to reason, you need causal reasoning, right? I think they're very good reasoning parrots. Like, they've seen enough text on the internet that looks like somebody is reasoning through a problem, and they can parrot that. But the fact that they hallucinate is a very, very good indicator of saying, oh, if they have not seen enough reasoning of this type, they're just going to hallucinate that reasoning.
Got it.
So yeah, that's definitely not the case.
That's good to know, though. That's actually good to know that they're not ready. I would hate for the first iteration of ChatGPT to say that they know exactly what Hesse's going to say next, right? So, okay, so are LLMs unbiased and objective?
They are as unbiased and as objective as their designers, right? So like very much like all other machine learning models, they're going to inherit biases from their data and from their design. So for example, one of the things that gave OpenAI an edge very quickly was that, quote unquote, alignment with human preferences. But which humans? Like humans that OpenAI said, you're the right group of humans to, provide preferences for the rest of the humans.
Right.
So
Okay, so LLMs can generate human-like text. They are truly creative and innovative.
I think the first part of that is correct in a sense that they are probably better than 90% of people in writing, grammatically correct and coherent text. Um, the true creativity, I have a hard time with that one. Even like things like mid-journey and stable diffusion and such. The majority of the creativity comes in pages and pages of prompts that somebody writes. Like that the content of that prompt is creative. The rest is just a model, replicating what it is told to do.
Right,
And I
right.
think that's the same with language models too.
Yeah, I found that like I had to on Midjourney to generate the logo that I wanted. It ended up taking about 10 to 15 prompts
Yep.
to get it to where I wanted. It was cheaper because I had a full year license, but from the perspective of time, I probably would have gone to somebody on Fiverr
Yep.
who probably could have developed it in half the time because I was prompting what I wanted when I completely did not rely on somebody who could have done it outside of the box without my interference.
Yep.
So I think there's some trade-offs. Okay. LLMs can continuously learn and expand their knowledge like humans. And I think you already said this one, but go ahead.
Yes, if you have a lot of money, because you have to keep retraining them, right? Like, and you have to keep retraining them from scratch almost, because they have this catastrophic forgetting problem where if you just throw in a little more data and try to retrain it, it's just going to forget some of the previous information. So the most robust way to do that is to retrain it from scratch, and nobody has that amount of money to just keep retraining these. There are a lot of other approaches like retrieval augmented generation, as you mentioned. But yeah, the models themselves, it's very like that's why OpenAI is keeping the model from 2021 and not updating it because it is expensive.
So explain how retrieval augmented generation works.
So that's essentially the easiest way that I like to talk about it is separating the knowledge base and the linguistic interface. So essentially, you have to admit right away that the language model is just a linguistic interface. It does not have knowledge. It should not rely on its knowledge. And separately, the data layer is where the knowledge exists. So that data layer could be actual, I don't know, structured data, could be documents, could be anything like that. So the role of the language model becomes, Hesse said this question, that is, what is retrieval augmented generation? Therefore, I'm going to make a query against these documents, figure out which paragraphs have a description that answers this question, bring them back, put them in the context of the LLM, and ask it to answer that question only using this text. So that way, you're using a reliable set of documents as your knowledge base, as your database. And the role of the LLM is pretty much understand what Hesse said and then provide a good answer based on these pieces of text that I'm giving you.
Okay, so you're basically now getting to more fine tune the model specifically for stuff that that's relevant, or I would say like a good reference point for the
Right.
output.
Yeah, so fine tuning as a term is something else, but you are essentially grounding it into a knowledge base that is
Got it.
reliable, if you
Got it.
wish.
Okay. Okay.
And that's very important because there is also a lot of nuances around, like when you're separating the data and the linguistic interface, very much like a normal website where the data layer is separate than the UI. And then the reason is that then you can put things like privacy control, access control, removal of PII and blah, blah, blah. Between these two, that's exactly what you can do here now, right? Because you can ask me a question that you're not allowed to know the answer to, and then this intermediate layer can just reject that question and say, hey, you're not allowed to ask this question.
Okay, got it. Okay, so the last myth or fact, LLMs are deterministic.
I think that everyone has seen already that you ask it a question twice and it gives you two answers. So.
Yeah. It's probably, I think, one of the reasons why if you end up building anything, even from a stronger compliance base, let's say in healthcare, that if it is deterministic, that's a good thing in a way, because now you have a better reliance on what the output could be.
Right.
But because of the way it is right now, generative AI is not even being considered as part of, let's say, FDA approval or anything like that, right?
Yeah, I mean, there are a few ways that you could get it closer. Like there's this parameter called temperature, which you can reduce, which makes it more predictable, not deterministic, but more predictable. Like grounding it into external knowledge source, like RAG does, that makes it more predictable. You could create verification modules that check the output and ask it to try again if it does something incorrectly. There are, there are also, if you're creating something custom, you could also, instead of asking it to generate one response, you could ask it to generate a few and then do a majority vote. There are ways to make it more predictable, but definitely deterministic is nowhere close to where it is.
Okay, so let's talk about some of the issues when it comes to generative AI. I think one of the biggest things that I'm finding, and especially between if you try to separate the haves from the have-nots based on the size of the tech company, there is a capacity and not knowledge limitation. Can you talk a little bit about that?
Yeah, for sure. I mean, the game of very, very large models is just won by the big entities, because that's where the compute resources are to run these models. But that's not all lost for smaller entities like startups, because one of the misconceptions is that LLMs can do everything. You just need to throw the right data at them. That's definitely incorrect. So you still have to do a lot of the right, product development steps of figuring out the right problem, figuring out the process for it, design for that process, create, the proper guardrails around that process for the software to work in, integrate it into the work. So it leaves a lot of room for startups to go out and figure out all of these details, which means that sometimes you might not even need the largest model. Sometimes for your use case, maybe a medium-sized model interface with a bunch of smaller models is a much better play. So I think that the knowledge gap, yes, there is a gap between available resources, but the opportunity, I think, is elsewhere. The opportunity is in the good old business bottom line, which is if you're creating a startup, go out, find somebody with a real problem, and figure out how to build software to solve that problem.
So you're basically saying that we don't have to throw out the old and assume that the new thing is going to replace it. Okay.
At least not in the near term.
Not in the near term. Okay, so let's talk about synthetic data. Okay, and so there's an increasing reliance on it for training these large language models. And so I read something about potential model collapse and the degradation of the quality because now we're creating new we're replacing data with synthetic data. Can you tell us more about what those impacts are?
Yeah, for sure. I mean, against the terms of service of most of these large models, a lot of the smaller open source models are trained on the output of the larger models. Generally speaking, there's this concept called knowledge distillation, where you could grab a very large model that does something, and then sort of distill it to a smaller model that repeats the majority of the behavior of the large model, but is more specialized in how it does so. So because of this dependency, there's a bit of a concern that depending on how the large model is behaving, the behavior of the smaller models might be dictated and constrained. And if we just keep doing this for a very long time, eventually it's just a closed loop. Like there is not enough diversity, which might or might not be true. Like I think the opportunities that exist in the near term is going to be all around essentially all the data that is not on the internet. So like from a research point of view, yes, there is a ceiling potentially, but from like a business opportunity point of view, there's so much out there. And most importantly, becoming very creative in creating an MVP that allows you to create your own data sets is the name of the game. That's the most important mode you could have, because the rest of this stuff is what everyone has access to. All the things on the internet everyone has access to, even the data that is owned by businesses. You could imagine that a competitor, a startup, is going to come up with a deal with them and get access to the same data. What will be super unique and most like for startups is always going to be the data that you can collect yourself, and in principle that's limited by your imagination, not really anything else.
Okay. So let's talk about, let me see, what one of the other issues that people are worried about is, okay, amplification of biases. As long as humans are involved, I would assume that biases are, commonplace.
Yes. But having machines do it is also not necessarily going to change that.
Yeah.
Because they're going to repeat the biases in data and the design. So the only answer is people sitting down and thinking carefully about, and bias is not always a bad thing. Like training is creating bias. So like having an inventory of all the biases, and then a taxonomy of these biases are bad and we don't want them, these biases are good, but this 99% of biases are sort of gray, so what do you want to do with them, right? Like the gendered language, for example, is a very good example that I like to talk about in this context, because English does have gendered language, but a lot of other languages like Turkish, Farsi, etc. don't. And when you translate from one to the other, it says, she's a nurse, he's a doctor. That's the canonical example. But maybe that's right. Maybe in a very specific situation, she's the nurse and he's the doctor. So like, what is the right product design? What is the right policy on top of this translation that allows that adaptability, that says, okay, well, are we talking about a woman or a man in a translation, right? But the system should be. So essentially what we do with biases is a very non-trivial thing for a lot of kids. Like there are some biases that are very clear are bad. Some biases are very clearly good, like alignment with general human preference. That's a bias we're creating, but that's a good thing.
Yeah.
So what to do with the gray area ones, those are the interesting questions.
Okay. Because that could be cultural, that could be that.
Absolutely.
There are a whole host of other values that you need to take in consideration. Okay, so let's turn a little bit to startups who are considering using these LLMs for their own purpose. From your perspective, because you work with a lot of startups who are starting to use LLMs, what do you think are the things that they need to consider in determining whether or not they, first of all, are they going to use this, or are they going to use, let's say, like you said, some of the traditional AI machine learning? And what do they have to think about when they decide to make the switch?
Yeah, so not skipping all the good practices is the baseline, right? Like you cannot skip getting out there and talking to customers. You cannot skip the right product development steps. You cannot skip the right software engineering steps. Like you have to do all the above, and that's like 95% of the game still. The thing that is different is that now you have one new Lego block to put inside the system you're creating to solve a specific customer problem. And that new Lego block has a bunch of new capabilities. So in all likelihood, though, whatever you end up building for a specific customer problem is not going to be just one model. Like in all likelihood, it will be probably one large model, a bunch of small models, all of them interacting with each other. And the IP will be really about how these are architected to work together, to interact with each other, to control each other, to scaffold the behavior of the large language model, and to verify it, guardrail it, and then what data is supporting all of the system, right? And because the data that is available on the internet is available to everybody, so what is your unique mode, data mode? So and again, like none of these are really new. Like all of these have been around forever. It's just being systematic, principled, evaluation driven, and really knowing what is it that you're trying to improve.
Are they? Is it going to be different executionally when you start to switch to large language models, because a lot of it is prompt based as opposed to actual programming?
Yes and no. So um, a lot of better a lot of the better models are a lot less sensitive to the exact details of the prompts, and a lot of well-designed systems remove the burden of prompting from the user and bake it into the back end to write the prompt. So a lot of the systems we design, we spend a lot of time understanding if the user says this, they might mean these things and they might need these types of information. So the prompt is written automatically in the backend that goes to the between ChatGPT is a bit of a weird product because the distance between what you're writing and the model is very short. In most proper, robust software products, that distance is much larger. Like what you write is analyzed and added and expanded, and like RAG is a very good example, right? Like what you write is not the prompt. So it does still take a lot of software engineering to create a modular system that automatically writes the right prompt. But and that's like 95% of the game. So about 5% of it is still, yes, like the backend has to have the right system prompts, and the user has to, and that problem will reduce over time as we include more data into the prompt about the user. But in principle, yes, it will still depend to some extent on how the user is saying things on the interface.
Okay. It seems to me that, and maybe this is a separate discussion about whether or not there is vulnerability for the software developer over time.
Vulnerability in terms of job loss?
In terms of job loss.
Yeah. I mean, there's vulnerability everywhere. What I have a hard time wrapping my head around, though, is the the whole conversation around job loss. I think is a little misguided and emotional. I think what is more likely to happen is a job description loss. Like so far you only needed to write in Python. Now you need to write in Python, but also be good at English, right?
Right.
Or maybe you're a business person. So far all you did was writing things in English. Now you need to write it in a very specific way that the model understands, right? So
Right.
these types of the details of the jobs are going to be fluid and change. But just wiping a whole job overnight, I think that's likely to happen. So the big question for me there is, how can tools like these that are automating some tasks within these jobs be used to then quickly upskill me to do something different that I wanted to do but I was not able to do before?
Okay, got it. So that brings us to our last question, and it's a good segue from your last comment, because we're talking about a technology that's going to be embedded everywhere, in business, in our daily lives, and how we communicate with each other. So philosophically, and you and I had talked about this just beforehand, what is your sense about dependence on a technology that's going to emerge in a way that has, I don't know, where it has implications on whether or not we can control it, that it can behave as intended, and whether or not humans will make the right decisions as it's being built out into society?
Yeah, I mean, it's a very valid and deep question, and it does have societal impact, right? Like I think as one of the topics that I talk a lot about is agentic workflows and multi-agent systems, and I think they will result in a lot of redefinition of work, right? Because as we just said, the job descriptions are going to change. They're going to turn into new job descriptions, but I don't think it's going to stop there. It's going to just change organizational structures. Like if a lot of the work that middle managers are doing today are that cognitive handling of transferring the business metrics into specific tasks for the ground workers, would we need them anymore? And if not, then what does it mean to have a corporate? If agents become very good at hiring gig workers to do something, onboarding them, having them do it, and then offboarding them, then what does it mean to even have the boundaries of a corporate? So there are a lot of very, very interesting impacts on the future of work, I think, specifically, but also in societal impact in general. As you said, I have a hard time, obviously it is very difficult for any of us, and I have a very hard time predicting where it will go. But, my bet is still going to be on founders who are enabled by money, capital, and connections and influence to build guardrails, to build alignment modules, to build privacy by design, to build responsibility by design. And that's the only way that I think we have a chance of controlling where this will go, or at least reducing the potential bad side of it. Because anything else that we would do, like regulations, like relying on corporations, none of these are going to be that reliable in terms of where we're creating the right balance to end up with the right outcome.
Unless you create an LLM specifically for governments that will accelerate, I don't know, their operations and even their thinking, maybe just to give them, hey, okay, hit me up on what happened in the last 10 years so that I can catch up to how to build an LLM.
Yeah.
Right? I mean, that's the reality is that I wish if government had the funds to invest in smart people the way tech does, then
Yeah.
maybe they would have the controls that they need in order to really fully understand how to legislate this technology. But that's the unfortunate part.
Yes.
And I think there is an imbalance here. It's capitalism that's taking over, right?
No,
So
absolutely.
anyway, any last thoughts? This is amazing. I wish I could talk to you forever.
Yeah, I know. These types of topics, we can definitely talk about them for days and days and days. But yeah, I mean, a lot of the rigid, societal structure that we have around governance, around work, around social interactions, I think a lot of these are going to fall apart, as these new technologies, get more and more embedded and integrated into how we work and how we live. Obviously, as you highlighted a few times, doing it responsibly is very important. Not bottlenecking that on one entity is very important, especially if that entity is large and is slow to move, like corporations or government. So I'm very interested and always excited to have discussions around what does this actually mean? Like, what are practical, realistic ways of, controlling where this is going to go? And I don't think control is also the right term to use. Like, I think really what we're looking for, what we're hoping for, is reducing the harmful sides and amplifying the useful sides, right? Like, because the same technology, yes, it can wipe out humans, but it could also potentially be an equalizing force in allowing people to have access to building companies that they never previously had because it was way too expensive for them to hire engineers and product people and So I think that that's really the balance that we have to figure out how to get right, like how to empower the good use cases and dampen the bad use cases.
Thank you. That's amazing. Thank you for that. Okay, so I think that's all we have time for today. And I thank you so much, Amir, for joining me to discuss this important topic. And I think for the most part, this is a topic that many people really need to understand, because it is now moved beyond the AI community to now like basically society. So I would make this available to everybody who wants to really understand this technology itself and how it's going to impact their lives in the future. So thank you. And for everyone else, Tech Uncensored is powered by Altitude Accelerator. It's produced by BlueMax and Transistor Radio. My name is Hessie Jones, and I am your host. And until next time, have fun and stay safe.
Thank you.